Hi guys, welcome to the SCNC1111 tutorial on mathematical modeling. Mathematical modeling is an important part of your group project, so make sure that you understand it. In this tutorial, we're going to talk about mathematical modeling. In particular, we're going to work on a demonstration question. First of all, what is mathematical modeling? It is a useful tool to predict the future trend. It is very suitable for solving open-end questions, meaning that the questions have no fixed answers. Say, different people can formulate different mathematical models to tackle the same question. Mathematics or statistics can be used to solve daily life or scientific problems without definite answers. In fact, this echoes with one of our HKU educational aim, which is to tackle novel situations and ill-defined problems. As you're going to work on the project as a group, this also echoes with the aim of communication and collaboration. Actually, mathematical modeling is very common nowadays. Take machine learning as an example. In supervised learning, you will provide some training data sets, and then you will use machine learning to figure out the function that best describes the relationship between your variables. And that is actually a mathematical modeling problem. If you have not done so, please refer to Lecture 5, Lecture on Mathematical Modeling, for more details before you proceed. Make sure that you come prepared. Now, let's start off by talking about the aim of your mathematical model. You will need to be clear about what you want to investigate or predict using your model. Make sure that you have clear definitions on keywords of your model. Say, maybe you want to rank the best restaurants in town. So here, what do you mean by the best? Is it the best in terms of value? In terms of time? And quite a number of you want to investigate the cost effectiveness of something. In this case, what do you mean by cost effectiveness? Make sure that you clearly define your keywords. After determining your aim and defining your keywords, we can move on to the 7 steps of formulating a good mathematical model. The first step is to define and identify variables. Your input will be the independent variables, and your output will be the dependent variable. Let's have a quick revision here. Dependent variable is value that result from your independent variables. And independent variables will be values that stand alone and will not be affected by the other variable we're trying to measure. In short, independent variables will affect your dependent variable. Now we can move on to step 2, which is to identify and classify factors involved. It is important that we classify factors as significant or insignificant factors, and we also need to make useful assumptions. The next step is to focus on the significant factors and formulate the model. So basically, you can just ignore the insignificant factors and exclude the insignificant factors from your model. Remember, the essence of mathematical modeling is to capture the salient or important aspects of your phenomenon. So you only need to take into consideration your significant factors. We need to describe how the significant factors affect one another and affect your dependent variable. Now, the next step will be to estimate the numerical value of the parameters. In your equation, there will be a number of constants probably. So you will need to find these unknown constants by references, guesstimation, measurement, or experiments, etc. And then we can proceed to solve the model. If your model is a differential equation or a difference equation, then you will need to solve it. Please note that difference equation is not on the syllabus of this course in this semester. And then the next step is to interpret the model. You may want to plot some graphs for your mathematical model. Make sure that you also interpret the model and infer something from your charts, instead of just pasting your graphs on the PowerPoint and then do nothing about it. The final step is to verify the model, which means you will need to make sure that you don't commit any mistakes, and you may want to think about how you can improve your model and discuss the limitations of your model. The 7 steps of formulating a good mathematical model may be a bit vague, so it's best to have some exercise together. We will now work on a demonstration question. Formulate a mathematical model for the yearly global demand for paper that is applicable for the coming 10 years. Here, the keywords are already highlighted for you. We're finding out the global demand for paper, and the time frame is the coming 10 years. So, let's try out this question. The first step is to define and identify the variables. We will first need to define demand for paper. What do we mean by demand for paper? It is defined as the total mass of paper, or its raw material, required to produce all paper products. And then we will need to move on to define the constituents of global demand for paper. We have 3 categories here. The first one is printing or writing paper, like books, newspaper, magazine, etc. And the second category is packaging material, like cardboard or paper bags. And the third category is tissue paper, and also others. Then we will need to identify the dependent and independent variable. The dependent variable, usually on the y-axis, here is yearly global demand for paper at T year after 2020. The unit is kilogram, and it is denoted as D. Make sure that you have stated your unit. So here the unit is kilogram. And then you will need to also clearly denote your variable. Here, the demand for paper is D. And then we move on to the independent variable. The independent variable here is time. It is usually on the x-axis, and the unit is year, and we will need to clearly denote it as T. And T is the number of years after this year. After we have defined all the stuff, we can move on to step 2, which is to identify and classify the factors involved. Remember, there are 2 types of factors, significant and insignificant factors. So what are the significant factors that would affect the demand for paper here? The first factor is the growth of global population. The higher the population, the higher the demand for paper. Makes sense, right? And then the second significant factor will be advancement in technology, meaning that there will be more e-products to substitute paper. The more the substitution, the lower the demand. The third significant factor is the increase in awareness on environmental protection. So we can recycle paper. The higher the recycling rate, the less the demand. Then we can move on to the insignificant factors that would affect the demand for paper. What will be insignificant? Here, the supply of paper will be independent of the demand. Price of raw materials in paper making is also insignificant because demand is independent of raw material costs. And the third insignificant factor will be economic development, because economy improvement has limited effect on paper consumption behavior. And don't forget to make useful assumptions to simplify the model. In fact, quite a number of you miss out this important part, which is to make assumptions in your model. We will consider printing or writing paper, packaging material, and tissue paper as the only 3 constituents of the demand for paper, so as to simplify this model. We will also take the contribution of each constituent and the population growth rate as constant in the coming 10 years. Now, let's move on to the third step. We focus only on the significant factors to formulate the model. Let's look at the first factor, which is the growth of global population. The higher the population, the higher the demand. So one goes up, another goes up too. this relationship is positive. We, again, clearly denote population as P, and P0 will be the population this year. We denote population growth rate as R, which is a constant, and the unit is percent. So we now obtain the term for factor 1, which is P0 times 1 plus R to the power of T. This describes the population each year after 2020. We can then move on to factor 2, which is about the substitute for paper. The more the E products, the higher the substitute rate and the less the demand. So one goes up and the other goes down, meaning that the relationship is negative. Here, electronic products would only substitute printing or writing paper. It makes sense, right? Because you will not have E version of toilet paper or packaging cardboard. So make sure that you pay attention to this. And the substitution rate is not dramatic. Thus, the decreasing rate of demand is assumed to be a constant. Again, we will need to have clear denotation. Denote annual consumption of paper per capita in 2020 as C. Unit is kg. So it means the annual consumption of total paper, all three categories add up together. And per capita means per person. And then we denote contribution of printing or writing paper to demand as A%. Denote the percentage decrease of yearly global demand of paper, and this is caused by the increasing use of electronic substitutes as X%. So this percentage decrease will only affect the annual consumption of printing or writing paper per capita, okay? Because you can only substitute printing or writing paper by E products. So pay attention to this chart here. C is the annual consumption of paper per capita, and A% of C will be the annual consumption of printing or writing paper per capita. So naturally, 1 minus A% will be the others, like packaging material and also tissue paper. Note that the factor about E product will only affect A here, because you can only substitute printing or writing paper with E product. Now we will have term for factor 1 and factor 2. Because factor 2 is in the unit of kilogram per capita, so you will need to multiply it by your population, factor 1. Let's look at factor 2 here. You can see in the yellow words that C times A. C times A will give you the annual consumption of printing or writing paper per capita, and you will need to multiply it by 1 minus X to the power of T. That is about the substitution of paper. And then you add another term, 1 minus A times C. It is about the annual consumption of tissue paper and packaging material per capita. Because E product cannot substitute these, so you do nothing about the term. Now let's move on to factor 3, which is environmental protection. The more the recycling, the less the demand. One goes up, another goes down. The relationship is negative. What are the assumptions behind? We assume all three constituents could be recycled, and the increase of recycling rate in the coming 10 years is a constant. We denote the percentage decrease of yearly global demand of paper due to the increasing recycling as Y%. So this will affect all three constituents of the paper. Now, we have all three factors considered. You can see the first three parts here, like the population and then also the annual consumption of paper per capita, this term here. We put a bracket around these terms and then times the whole thing by 1 minus Y to the power of T. Why do we need to do so? Because 1 minus Y will actually affect all three categories of paper here. Okay? So then we have obtained our final model, which is the demand, D, is equals to all the terms here. You may notice that there are some constants to be determined here. So step 4 is to estimate the numerical value of the parameters. We can obtain the numerical value of the parameters by references, by research or experiments, etc. So we substitute all the parameters inside your model, and we will have your final model. So here you can see clearly that the dependent variable will be D, and it is the yearly global demand for paper, and your independent variable will be T. We can now move on to step 5, which is to solve the model. We don't have any difference equations or differential equations here, so we can skip this step. Move on to the next step, which is to interpret the model. We can substitute T equals to 0 to 10 to predict the global demand for paper, and we can plot graphs to visualize your model. You can even try different values of X and Y to see the effects on the demand. Move on to the final step, which is to verify or check the model. We will need to make sure that we did not commit any mistakes. We will have to go back to the assumptions. We have to make sure that the assumptions make sense. Is it true that there are more constituents contributing to the global demand for paper? Maybe there are other things other than the 3 categories that we have just considered. You can consider more significant factors if you want. And are the rates really constants? We assume that the rates are constant here, but is it really appropriate? And actually, can all constituents be recycled? Can tissue paper be recycled? You will also need to check if you have committed some common mistakes, like adding up factors of different units, or maybe your model is lacking predictive power. Say it can give prediction of a clear trend of output. Remember, there is no correct model, only useful ones. Make sure you have considered the most useful factors. As I have said, mathematical modeling is suitable for tackling open-end questions, and this demonstration question is actually open-end. So you can actually have different approaches to this problem. Say for the 3 types of paper, you may want to replace packaging paper with decorative paper. And you may also consider how the demands of the 3 types of paper are affected. Say if there is less festive atmosphere or increase in environmental awareness, you will have less demand for decorative paper. Or for increased population, the most significant effect may be the increase in tissue paper use, but not others. You may also consider other ways to build the model, for example, by different industries. Like the clothing industry and the manufacturing industry have different demands on paper. You may also consider the size of paper. And that's it for this demonstration question. Now it is your turn. We have a working problem for you. Formulate a mathematical model for the yearly global demand for rice that is applicable for the coming 10 years. You will need to work with your project groupmates and submit a document. Don't worry, we will provide some guidance for you. We will need to follow the 7 steps of mathematical modeling. The first step is to define the demand of rice. What constitutes the demand of rice? And then we can move on to identify the factors and make assumptions. You can choose one approach to start. For example, by age group, venue, region, or others. For age group, you have kids, teens, adults, elderly. They all have different demand for rice. And for venue, you have household, restaurants, schools, hospitals. And for region, Asia is actually the major consumer of rice. You can also consider factors like population, economic development, substituents for rice, and consumption behavior. And the rest of the steps, you will need to do it on your own. You may always refer to this tutorial. In conclusion, we have talked about the 7 steps of formulating a good mathematical model today. I hope that by now you all have a clearer understanding on our expectations on formulating a mathematical model. Thank you, and as usual, if you have any questions, feel free to contact us. See you next time.